Good evening. I'm very happy to see you over this video once again. And one more thing, I'm very happy for your support which you have given over this. It's really amazing. Fine. I have been explained some problems from yesterday video based on the central forces, right? Today also I would like to explain some other problems, how to apply the concept of central forces. I hope so you can understand from this how to apply this thing in electrostatics also. This is the basic thing how to apply in electrostatics also. Okay. So here in this one there are four identical masses are there. These four identical masses are kept at the four positions, that is A, B, C and D, where A, B, C, D are the 4 points. Now we would like to find the force acting at D point, correct? Now if I am choosing this A and C, this is the direction of here we kept the mass is m, even though here kept the mass is m. Now here there is a 100 mass is there, that mass is m, and this m it experiences the force this direction. And similarly there is another mass, this mass it experiences the force this direction. These two distances is also same and magnitude of force is also same, but the thing is they are equal and opposite. So if they are equal and opposite, they cancelled by each other. That's why effect upon this mass due to remaining two, that is A and C, is equal to 0. Now let's come to the point. There are three points are there, B, C, D. This is A by 2 and this is A, this is root 3 by 2A, right? So from this one, A square is equal to B square plus A by 2 whole square. It is nothing but Pythagoras principle. From this Pythagoras principle, A square minus A square by 4 is equal to B square. AC 3 A 3, A square is equal to B square, that is equal to root 3 by 2, that BD value, right? Now we know that according to Newton's inverse square law, F is equal to Gm1 m2 by Bd square, where Bd is the distance between these two masses, and m is Gm square divided by 3a square by 4. Finally we are going to get 4 by 3 Gm square by a square is the force experienced by, this is the force experienced by the mass which is kept at the point D. So this is the one of its application, alright? Yes. Next problem. Next problem is there are two masses are there. This is a first body of mass is m1. It is at infinite distance. Even the second body of mass is m2. It is also at infinite distance. Due to the gravitational gravitational pull, they are approaching each other with an acceleration of a1 and a2. If they are approaching each other, what is the relative velocity of approach? This is the question. In this question, if you are going to speak about the relative velocity, we should know about first what is the force between. That force is given very clearly that it's a gravitational pull. That means there is no external force acting upon the system. In this system, F is equal to Gm1 m2 divided by a square. But we know that from the Newton's second law, F is equal to m1 a1. If I am equating equation 1 and equation 2, m1 a1 is equal to G m1 m2 by r square, and both sides m1 side cancel. a1 is equal to G m2 by r square. Like A2 is equal to G m1 by r square. This is the one which we are. Relative acceleration A1. This is A1 minus of minus A2. Why? Because of one body is moving this direction, other body is moving this direction. So both are moving in opposite direction. That is why A2 becoming minus of A2. Minus of minus is plus. Acceleration, relative acceleration A is equal to A1 plus A2 when they are in opposite direction, according to definition of acceleration dv by dt. Now I am dividing and multiplying with the dr. There is no changes in this value, which is equal to gr square by m1 plus m2. But here you may get the doubt, why should we take the negative value? Because of if the distance is decreasing with respect to the time, the rate of velocity is becoming negative. Minus of v dv by dr is equal to g by r square into m1 plus m2. So I'm applying integration on both sides. This is minus come out of the integration. After the integration, minus v square by 2 is equal to minus of g m1 plus m2 divided by r, and both sides minuses are cancelled. This go to here, 2g m1 plus m2 divided by r, and the root is equal to relative velocity of approach after two bodies when they are separated by infinite distance. So again, one other problem here we are going to discuss. There are n number of identical particles, each of mass is m, are placed at distances 1, 2, 4, 8 and so on, positive x-axis. You have to find the magnitude of the force experienced by the mass which is placed at the horizon. This is the question is. And this question, between these two one mass, let it be that between these two one force, let it be F1, between these two, let it be F2, F3, F4 and so on. It follows the principle of superposition, but according to Newton's square law, F is equal to g m1 m2 divided by r squared. F is equal to F1 plus F2 plus F3 plus F4 and so on, where F1 is equal to gm square by 1 square plus gm square by 2 square plus gm square by 4 square plus gm square by 8 square and so on. That we are writing gm square is common, 1 by 1 square plus 1 by 2 square plus 1 by 4 square and so on. These all are in GP. Yes, infinite is equal to a divided by 1 minus r, where r is equal to 1 by 2 whole square, that is 1 by 4. So that 1 minus 1 by 4 by 3, f is equal to gm square into s infinite. Then 4 by 3 gm square is nothing but the magnitude of the force experienced by the body. Look at here, one more problem, that is, these are the three identical spheres, each of mass is m. Now these spheres are kept in such a way that each one touches the other. What is the force experienced by the one of the sphere due to remaining two spheres? That is the problem. Right? If you are going to do this one, mass of the sphere is m. Now in this case, force F is equal to, according to Newton's inverse square law, force F is equal to g m1 m2 by r square. But all the spheres are identical, so that m1 is equal to m2 is equal to m3 is equal to m. Now r is equal to 2 capital R, where capital R is the radius of the sphere. Now f1 is equal to f2 is equal to g m square, where r is equal to 2r, then 4 capital R square. If according to parallelogram law of vectors, resultant force F is equal to F1 cos theta by 2, where theta is equal to 60 degrees. then F is equal to 2 gm square by 4r square into root 3 by 2. Then F is equal to root 3 by 4 into gm square by r square. If you wish, you can do this one. These are the point masses. This is one mass, other mass. It forms the equilateral triangle. This is the force experienced by this mass due to this mass. This direction, that will be F2. And this is F1. The angle between F1 and F2 is equal to 60 degree. I applied it here, and then I am going to get this value. Then finally force F is equal to root 3 by 4 gm square by r square is the force experienced by any one of the sphere due to the remaining two spheres when they are touches with each other. In a double star system, that means this is one body of mass is m1, other body of mass is m2. Now this is called a double body system, star system, stair system, and the distance between these two bodies is d. Now these two are rotating about their common center. Here masses are different. If masses are different, their common center from m1 is at a distance of r1. Then r1 is equal to m2 divided by m1 plus m2. Let it be equation number 1. Now, according to Newton's inverse square law, the force F is equal to gm1 m2 by d square, where d is the distance between these two masses and the masses of the each star. One star is m1, other star is m2. Then F is equal to m1 r1 omega square. Why? Because of it is rotating system. If it is rotating system in the sense, one experiences the centripetal force. That centripetal force formula is equal to m1 r1 omega square. Now I am taking equation 1 and 2 are the same. m1 r1 omega square is equal to gm1 m2 by d square. That is, on both sides m1's are cancelled. r1 omega square is equal to g r1 gm2 by d square. Again I substitute the r1 value, where r1 is equal to m2d divided by m1 plus m2. I substituted here m2 divided by m1 plus m2 into d omega square is equal to gm2 by d square. m2 is cancelled on both sides. Then omega square is equal to this m1 plus m2 is in denominator, go to the side becoming the numerator. gm1 plus m2 divided by d into dq. Omega is equal to root of gm1 plus m2 divided by dq. This is the velocity of the angular velocity of the planet. Here he is asking what is the angular velocity of the planet in a double star system. That value is equal to root of gm1 plus m2 divided by dq, with the angular velocity of the planet in double star system.